Arithmetic mean. Most commonly used, simply called mean. Add all the observed values. Mean equals sum n. Sample mean is denoted by. Population mean is denoted by mu. Example. Age of 10 pregnant women. 26, 31, 25, 21, 26, 26, 27, 25, 27, and 26. Sum equals 260. N equals 10. Mean equals sum n equals 260. 10 is equal to 26 years. Median. The median describes literally the middle value of the distribution. Divides the distribution exactly into two halves. Useful when there are extreme values. Example. Duration of hospital stay of 11 patients. 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 77. Median is the middle value equals 6. If n is even, then take the average of the middle two values. Mode. The mode is the value that occurs most frequently. Mode is the only location statistic to be used for nominal data, not a measurable characteristic. Epidemiology. Describing an epidemic with respect to time. Example. Color preference of people for their car. Color preference. No of persons. Green, 354. Yellow, 852. White, 310. Red, 474. Mode equals yellow. Range. Definition. The difference between the minimum and the maximum value of the observations. Advantage. A quick and easy indicator of dispersion. Disadvantage. Influenced by extreme values. Uses only 2 data points. Interquartile range. Quartile deviation. Definition. Defined as the interval between the value of the upper quartile and the lower quartile. Interquartile range equals Q. Advantage. Unaffected by extreme values. Disadvantage. Covers only the middle 50% of observations. Mean deviation. Definition. The mean deviation is the average of the absolute deviations of the observations from the arithmetic mean. Advantage. It is based on all the observations in the group. It is easy to grasp the meaning of the procedure. Disadvantage. It ignores the sign of the difference between the value of the observation and the arithmetic mean. It is not widely used because of the availability of a more advantageous measure. Standard deviation, SD. Definition. The SD is the square root of the average of the squared deviations of the observations from the arithmetic mean. The square of the SD is called variance. Advantage. The SD is the most important measure of distribution. While variance is in units squared, the SD is expressed in the same units of measurement as the observation. It is suitable for further analysis. The SD, together with the arithmetic mean, is useful for the description of the data. Coefficient of variation. Purpose. To compare the relative variability in different groups. Definition. The coefficient of variation is the standard deviation expressed as a percentage of the arithmetic mean. Types of data. Qualitative. Nominal, e.g., color of eyes. Ordinal, e.g., stages of disease condition. Quantitative. Discrete, e.g., family size. Continuous, e.g., height weight. Prevalence. Number of existing cases in a defined population at a specified point of time. In some studies, the total population is used as an approximation if data on population at risk is not available. Point prevalence. Measures the frequency of disease at a given point in time. Applies when the data has been collected at one point in time. C equals number of observed cases at time t. N equals population size at time t. Example of point prevalence. -150 children in a school. Screening for refractory errors at time t. -15 children require glasses. Prevalence of refractory errors. 15. 150 equals 10%. Period prevalence. Measures the frequency of disease over some time. Applies when the data has been collected over a period of time. C equals number of prevalent cases at the beginning of the time period. I equals number of incident cases that develop during the period. N equals size of the population for this same time period. Exercise. Scenario. Population of 150 persons. Follow-up for 1 year. -25 had a disease of interest at the beginning. Another 15 new cases developed during the year. Calculate. Point prevalence at the start of the period. Period prevalence for the year. Incidence. Number of new cases in a given period in a specified population. Time must be specified. Measures the rapidity with which new cases are occurring in a population. Can be expressed in absolute numbers, in terms of cumulated incidence, in terms of incidence density. Cumulated incidence, also known as attack rate, assumes that the entire population at risk at the beginning was followed up for the time period of observation. Incidence density, also known as incidence rate, reflects more exactly the person time observed. The relation between prevalence and incidence. Prevalence depends on incidence, duration of the disease.
1. Incidence I equals frac number of new cases, text population at risk. Prevalence, P equals frac text, number of existing cases, total population. 3. Cumulative attack rate, text number of new cases, population at risk at start, times 100%. 4. Incidence rate, ID, incidence density, fraxed, number of new cases, total person time at risk. 5. Secondary attack rate, SAR, SAR equal number of exposed cases, total exposed 100%. CFR equal frac text, number of deaths due to the disease text, total number of diagnosed cases times 100%. Keynotes, expressed as a percentage multiplied by 100. Measures lethality of a disease among confirmed cases. Example, if 50 out of 1,000 COVID-19 patients die, CFR equals frac 50 1,000 times 100% equals 5%. Exposure outcome, exposed, unexposed. Yes, A, B, C, D, HASHEP. Outcome rate exposed. Outcome rate equal frac A plus C, not exposed. Outcome rate not exposed is equal frac B plus D. Relative risk, RR, frac outcome rate exposed and not exposed. Outcome A bar A plus C, B bar B D. Interpretation. If the relative risk is in 1, then the risk of disease is similar in both exposed and unexposed groups, and the exposure is not associated with the disease. If the relative risk is greater than 1, then the exposure is considered to be positively associated with having the disease and could be a risk factor. If the relative risk is less than 1, then the exposure is considered to be negatively associated with having the disease and could be a protective factor. Exposure, disease, case, no disease, controls. Exposed, AB, unexposed, CD. Odds of exposure in cases equal fracs. Number of cases with exposure. Number of cases without exposure equals frac A, C. Odds of exposure in controls. Odds of exposure in controls equals number of controls with exposure, number of controls without exposure, frac B, D. From my text odds ratio equal frac text odds of exposure in cases, odds of exposure in controls, E, B, D, frac A times D, B times C. If the odds ratio is 1, then the odds of exposure among cases is the same as the odds of exposure among controls. This means the exposure is not associated with the disease. If the odds ratio is greater than 1, then the odds of exposure among cases is greater than the odds of exposure among controls. Therefore, the exposure may be a risk factor for the disease. If the odds ratio is less than 1, then the odds of exposure among cases is lower than the odds of exposure among controls. Therefore, the exposure may be a protective factor against the disease.